Morning, students. Yesterday, in the last class, we were discussing equations of two-dimensional motion. First, when a body moves with uniform velocity, and the second, body when moves with a uniform acceleration. Right? Every equation, two-dimensional, we have seen it is a combination of two linear equations. Equations of linear motion, one along the x-axis and other along the y-axis. Right? That is a very important topic. You must learn that also, and also related questions and numerical problems, very important. Right? Today, I am going to explain you projectiles. Now, the question is, what are projectiles? Projectiles are bodies which are thrown from the surface of the earth or at a certain height above the surface of the earth. Projectiles are best examples of what you call motion under gravity, right? So projectile can be two types. One is horizontal projectile and the other is oblique projectile. Horizontal projectile is the one that is thrown from a point at a height above the surface of the earth, right? Just like this one. Suppose this is y-axis and this is the x-axis, and a body is thrown from this point with a velocity u. The body cannot move along the direction of the velocity because the motion, once the body left from the hands of the person who is throwing, the body came under the action of gravity. So it cannot move along the direction of velocity. So what happens? The body comes in a curved path like this, a parabolic path like this, and falls at this point. Suppose this point is O, this is O, and this is C, etc. This is origin. You are standing at this place and you are throwing a stone in the horizontal direction. This is called horizontal projectile, right? Every projectile motion is the best example of motion under gravity. Motion under gravity means its acceleration is only acceleration due to gravity. For example, suppose this body is thrown along this direction. Body has no acceleration in the direction of the initial velocity. Actually, it's always acting downwards. So what happens is that at the beginning of the journey, the horizontal velocity is u, vertical velocity is equal to 0. Horizontal velocity, we can say that means velocity along the x-axis, that is equal to ux. Ux is equal to u only. What is ux? That is the initial velocity in the x-axis direction or in the horizontal direction. That is equal to u because the body has been given a horizontal velocity. Therefore, ux is equal to u. Initial velocity in the x-axis direction is u. But initial velocity in the y-axis direction, that is equal to 0. That is uy is equal to 0, right? And also, I can say ax. Ax means acceleration in the direction of the x-axis or in the horizontal direction is equal to 0. Why? Because this is a motion under gravity. In a motion under gravity, the acceleration is always acting downwards. Therefore, we can say ay is equal to G, I can write. Ay means in the downward direction. In the y-axis direction, downward direction, the acceleration is equal to G. So what is happening is that when the body is left from the hands of the observer, the man who is doing this experiment, he observes that the horizontal velocity always remains a constant, but vertical velocity changes with the time, right? Vertical velocity initially was equal to 0, but acceleration is in the vertical direction. Hence, from 0 velocity initially, the vertical velocity goes on increasing, but initially it was equal to 0, right? But the horizontal velocity all along the journey of this body, the horizontal velocity will be always a constant. Initially it was u, and any point you see, the horizontal velocity will be same, but vertical velocity goes on increasing. For example, this is at this point horizontal velocity is u, and initial vertical velocity is equal to 0. Suppose we take this point of the journey of the moment, then also the horizontal velocity will be of the same length and the vertical velocity increases. This is Vy and this is Vx. If you see another point here, the horizontal velocity will be of the same length, but vertical velocity now again increases. Right? If you take this point, the horizontal velocity will be same length, but the vertical velocity again increases. So when it reaches the surface of the earth, the body reaches the surface of the earth, its vertical velocity will be very high. It is very, very maximum. But the horizontal velocity remains constant. Why the horizontal velocity remains constant? Because in the direction of the horizontal velocity, there is no acceleration. Because every projectile motion is the best example of motion under gravity. In motion under gravity, the acceleration is only acting downwards, due to which the initial zero velocity in the downward direction goes on increasing. First of all, it is very small. Now it is again again it increases, and finally, when it reaches on the surface of the earth, it goes on. It becomes a very high value. This is what there are so many examples of this kind of projectile. This is called horizontal projectile. I must write horizontal projectile. So horizontal projectile means from the sun. This is ground. From the ground level, at a height above the ground level, a body is thrown. Right? Just like suppose a person, a soldier is standing on the top of a tower and he is operating a gun. So when the bullet comes out of it, when the bullet just comes out of the barrel of the gun, it is a projectile. It is a horizontal projectile, right? It will follow a path like this. The path followed by a projectile is called a trajectory. What is called a trajectory? Trajectory, it is called. Path followed by a projectile is called a trajectory. Understand? So this is what is called horizontal projectile. So every projectile, projectile, whether it is horizontal projectile or it is oblique projectile, both are the best examples of uh, motion under gravity. Right? A stone is thrown in the forward direction. I mean, in the horizontal direction. So when it leaves the hand, its velocity was in the horizontal direction. After that, then the velocity, then the direction of the body goes on changing. It goes on, what's inclined, or it is deviating towards the ground, and it follow a parabolic path and fall on the surface of the earth. Why it is falling? Because the acceleration is in the y-axis direction, the vertical direction, right? Because the vertical velocity always changing because it is acted upon by a downward acceleration. The velocity in the horizontal direction always remains a constant because in the horizontal direction, in what is called motion under gravity, there is no acceleration. This is the condition, right? So in this case, a few equations. So we have to derive. First of all, I will write initial velocity in the horizontal direction is ux is equal to u, ax is equal to 0. Yeah, uy also, yeah, uy is equal to 0 because initially the velocity is only in the horizontal direction. That is why ux is equal to u, you have done. Uy is equal to 0, you have done. Ax is equal to ax means the acceleration along the x-axis is equal to 0. So for the whole, first of all, I will discuss the horizontal motion of the body. Horizontal motion of the body, because so this is a two-dimensional motion. In two-dimensional motion, this is a two-dimensional motion because suppose this is y-axis and this is x-axis. The body is taking its trajectory in a plane. Right? The motion is controlled by two axes, x-axis and y-axis. Am I correct? The body travels both in the x-axis direction and also the y-axis. This is vertical and this is horizontal. There is a vertical motion and also there is a horizontal motion, right? So because it is two-dimensional motion. In two-dimensional motion, every quantity has two components. Displacement has two components, velocity has two components, acceleration has two components. I told you that. That only we were discussing in the previous class. Am I correct? So when we discuss suppose the distance moved when the body reaches the ground, when the point of projection, once it is projected and is falling at a point in a time t seconds, right? Then the body has a vertical distance traveled by the body is the OY, right? And what's the horizontal distance? That is equal to YC. YC is the horizontal distance, and also OY is the vertical distance. Body travels two distances. Body has two displacements. One is vertical displacement, and other is horizontal displacement. First of all, let us consider the horizontal motion of the body. For horizontal motion of the body, we can write x is equal to, x means total displacement in time t in the horizontal direction is equal to x0 plus x0 plus x is equal to ut plus half a t square. And x0 means initial displacement in the x-axis. x0 plus ux into t, ut plus half ax into t square. Right? So this is x0 means in the initial time t is equal to 0, the body was in the origin only. Therefore, x0 is equal to 0. This is equal to 0. You will write plus ux is equal to u only into t plus half into ax is equal to 0 into t square. Therefore, you will get this as equal x is equal to u to u again. In the horizontal motion, you can write x is equal to ut. X is equal to ut, right? Because displacement along the x-axis direction is equal to velocity into time. When we take displacement is velocity into time, when the body moves with the uniform velocity. No doubt, the horizontal motion is the motion with the uniform velocity only, because horizontal velocity always remains a constant. So horizontal motion of the body is a uniform motion with a constant velocity. When a body moves with the uniform velocity or constant velocity, then displacement is equal to simply velocity into time. That is why we got x is equal to u into t. Am I correct? Okay. One is a uniform motion, and other vertical motion. When I will talk about vertical motion, that is uniform accelerated motion. So, if projectile motion is a combination of two motion, one is uniform motion and other is uniform accelerated motion. Uniform motion means a body is moving with the constant velocity. Uniform accelerated motion means a body is moving with constant acceleration. So, first one, horizontal motion was a uniform motion. That is why uniform motion displacement is equal to the constant uniform velocity into time, or time t is equal to x by u. You can write this. We can take as equation number 1. Am I correct? T is equal to x by u. Now I am considering vertical motion. Vertical motion means when the body is projected and it travels through this trajectory. This is a parabolic path and reaches the point of C. Then the body describes two displacements. One along the x-axis. The body has come down to this much distance. That means O to Y level the body has come. That means the vertical plane, the body travels OY distance. Suppose OY distance is equal to Y only. And in the horizontal direction, the body travels YC is equal to X distance. There are two displacements the body has. So hence I can say that the body has two motion. One is called horizontal motion, other is called vertical motion. Now I am considering second vertical motion. For the vertical motion. For the vertical motion, I can write y is equal to, that means total displacement in vertical direction. Y is equal to y0 plus uyt. Why uyt? Right? That means the body is in the vertical. We are concerned with vertical motion. All the quantities must be vertical. So y is equal to ut plus half at square. Y0 plus uyt plus half ay half ay into t square. S is equal to ut plus half at square. Then why y0? Y0 is the initial displacement when time t is equal to 0. If the body is not at the origin, but at a distance y0 away from the origin, then this is general expression. Am I correct? But at the position when, at the point of time when the body was projected from the origin. Therefore, y0 is equal to 0. Therefore, this is equal to 0 plus uy is also equal to 0 only. Right? U is also equal to 0 only. That is plus half into ay. Ay means this minus I have